In this lecture, let us talk about the storage structures mechanisms that are attached to the database management system. The effectiveness of any database management system is measured by the speed at which it operates, and the speed depends on so many factors. First, the design should be perfect, and the data organization has to be optimal. And the next important issue is the storage. Ultimately, whatever the design of the database may be, whatever be the organization of the data may be, it has to be stored on the storage structures. So we need to understand what kind of mechanisms are available for storage, and what are their speeds, and what are their advantages and disadvantages. Unless we understand this, we cannot design a proper storage mechanism for a DBMS. Again, not all database management systems will have a unique or as a given set, same set of storage plans. No, we need to plan our storage structures in such a way that from the available resources, from the available various types of sources, we need to plan in such a way that it best suits to our requirements. In the sense, always customers, whenever your users who are operating on the database, will try to get the answers for the queries very quickly. So we need to give them, process their queries very quickly, and we need to have a mechanism that suits their requirement. The first one in the hierarchy is a cache memory, which is memory attached to the CPU, which has a limited capacity of the order of 32 GB or so, which is very quick and which is attached to the CPU. And this is highly prone to the crashes. This is attached to the CPU, and the cost wise also is costly. And the second one is a main memory. Main memory is also attached to the CPU, and capacity wise a bit better, higher capacity is there with respect to the cache memory of the order of it goes into the several gigabytes. Volatility is also there still. The third variety is of flash memory, which is different from the previous two memories. This is not connected to CPU. This is a bit slower when compared to these two, but a bit reliable. Reliability is more, and capacity is also more, but has its own limitations in terms of the read and write cycles are limited up to 1 million or so. Usually these kind of memories are attached to the digital cameras or embedded systems. When it comes to magnetic disks, the data is stored on rotating disks, which are coated with a special type of material which can be magnetized. The actual data is stored in the form of magnetized and demagnetized regions, which can be read or written through a special type of head, and which can locate on the disk. The disk is divided into tracks. Each track is divided into sectors, and the data is organized in the form of sectors, then tracks over the disk. The capacity of these disks to hold the data can reach up to several terabytes, and the data has to be transferred from main memory to the disk and disk to the main memory. It is not directly attached to the system, and data has to be transferred between these two. So the speed at which they operate is a bit slower when compared with the remaining memories. Another variety is optical disk, which is similar to the disk, but the mechanism that is used to read or write is different. Here a laser is used to write the data. It's a burning process to burn on the disk. Again, a head will be there to read out the burned and unburnt parts of the disk, and that's how the data is read. The capacities are much larger when compared with the magnetic disks, and volatility, they are much safer than magnetic disks, and we can have multiple reads and writes. The reliability is much better. The last one is a tape storage, where data is stored on magnetic tapes. The capacity of these magnetic tapes is very huge. The capacity can run into petabytes, and the only negative point in these tapes is the access is sequential. In the sense, if you want to access a particular part of the data on this tape, I have to run the tape to until that location, and then I have to access. I can read. So that's the only negative point. And cost wise, it's very cheap when compared with all the other storages. and volatility highly non-volatile, highly reliable. Now, with this background, let us observe the hierarchy among the storage structures, starting from the cache memory, then main memory, flash memory, then magnetic disks, optical disks, and magnetic tapes. Cache memory, starting from cache memory, the processing speed is much higher when compared with others. So processing speed decreases when we go down. Similarly, the cost wise, cache memory is costly and the cost decreases with respect to at each level. So magnetic tapes are much cheaper when compared with cache memory. And stability wise, cache memory and main memory are less stable or highly volatile, and the remaining things are when compared with the remaining ones. They can also be classified as primary, secondary, and tertiary type of storages. Cache memory and main memory is treated as primary type of storages, which are highly volatile and which are attached to the CPU. The secondary one is flash memory and magnetic disks. They are non-volatile, but they are a bit slow when compared with the primary ones. And the capacity is also limited. When it comes to the tertiary, optical disks and magnetic tapes are with huge capacities, highly stable, and but a little bit slow in processing. Now let us try to spend some time on understanding the disk magnetic disks. The magnetic disk system usually consists of 1 to 5 disks which are attached to a controller. This controller acts as an interface between the computer systems and the storage unit. Whenever there is a request from the computer system to read or write on the magnetic disk system, this controller used to identify the correct location on the correct disk. Usually these disks are, every disk is divided into tracks. Every track is again divided into sectors. And this controller, whenever it reads, it computes the checksum value. It computes the checksum value, which ensures the correctness of the data also. Whenever it writes also, it used to compute the checksum to ensure the correctness. And it also maintains bad sectors. Whenever there is a particular sector is got corrupted, when the checksum fails, then it identifies the bad sectors and keeps a mapping of the bad sectors as well. Apart from the traction sectors, data is also accessed in terms of the cylinders, where the ith cylinder refers to the data across all the plates or disks which are located on the ith track. The advantage of this is that the reading head need not move. Only the rotational latency will comes into picture here. Only if all the disks rotate on that particular track, the data can be accessed in the ith cylinder. The performance of the magnetic disk systems is measured by the following 4 parameters. One is the access time. Access time is the time it takes by the system when it receives a read or write request to the point of time when it transfers back the data. So the time gap between these two is taken as access time. The second one is seek time. Seek time refers to the time it takes to the head to relocate itself from the current position to the correct track where the data is present. And the rotational latency is the time it takes to identify the correct sector on a track. And the fourth one is a data transfer rate. This refers to the amount of data that is being transferred per second. Usually different systems used to have different rates. It usually ranges from 300 to 512 MB per second. Another important parameter for magnetic disk systems is mean time to failure, MTTF. It actually refers to the average time the disk runs continuously without any failure. Usually these disks used to run continuously for 3 to 5 years without any failure, and the time it takes is on an average it varies from 5 lakh to 12 lakh hours without any failure. But interesting fact is that if we maintain a collection of such disks on a single disk system, the average, on an average, the mean time to failure comes down to lower values. Suppose, for example, if I take 1000 disks on a system, each disk has, let us assume, the 12 lakh hours of continuous running time. then what is the mean time to failure as an entire unit comes down to 1200 hours, right? So the probability of failure is once in 1200 hours. So then even if one disk fails, the system has to take care of it. Another important feature in the storage mechanisms is maintenance of disk subsystems, where a large number of disk systems are connected through a computer through a controlling functionality, which actually guides the data transfers between the computer systems and these disk systems. The interface standards are there. Several interface standards are there, like ATA and SATA, SCSI, and SES. These are all variety of standards that are specified for data transfers and interconnections. Each one of them have their own advantages and disadvantages, and they have their own variable speeds also. Each one of them has their own speed levels. Usually they range from 300 Mbps to 512 Mbps. And apart from this, there are two more concepts of storage area networks and network attached storage. In the concept of storage area networks, a large number of disks are connected by a high-speed network through a number of servers. That means parallelly servers can operate on these disks, so that data access is much faster. So each server will try to access a specific disk system which is connected to it through a network, high-speed network. That is storage area networks. Whereas when it comes to the network attached storage, the interface is at the file level, and so the disk not at the disk level but at the file level. So data transfers will occur in the file formats, and file transfer protocols are specified, and using those file transfer protocols, data is being transferred across the disks. So here in this case, the view is not at the disk level but at the file level, but these files operate on the disks. That's how the data stores are being maintained. These are all various possibilities, and depending on the requirements, we can choose a particular mechanism to work with.